What's up, my dudes? Problem 3A, exam 4. This is some fun stuff. Fun stuff, you know? So, given the function f of x equals 2x minus 4 on the interval negative 1 to 6, find the area using different methods. We have a few different methods. So, on question A, it's telling us to graph it and find the area under the curve with geometry. We can do that. So we're going to make a graph. We're going to make let's go with the 10 by 10. Yeah, 10 by 10 will be good. 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 by, or I guess it's a 20 by 20 actually, but it's each axis has got 10. Each one's got 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got a 10 by 10 little square graph right here where we're gonna graph down all of our shit. I mean, I didn't say that. Or I didn't say what you think I said, actually. So graphing a line is pretty easy. I'm not gonna go into depth on how to graph the line, but basically, from our points, negative 1 to 6, it is a linear graph. So what is f of negative 1? That would be 2 times negative 1. That is negative 2 minus 4. So we're starting out at negative 1, negative 6. 1, 2, 3, 4, 5, 6. Here's our starting point. Here's our negative 1, negative 6. And 6, f of 6, what's 6 times 2? 12 minus 4, 8. 1, 2, 3, 4, 5, 6. So we're at x equals 6. We're going to go up to 8. 2, 3, 4, 5, 6, 7, 8. And we're at our point 6, 8. Cool. And we're going up at a rate of 2. That means for every 1x, this goes up 2y. And here is our f of x. Here's our f of x. And we're trying to find the area under the curve. When it goes under the x, it's actually the area, I guess, over the curve, if you will. But it's not even a curve. So it's just the area, corresponding to whether it's a positive or negative area or whatever. So, yeah. Okay, so we have a triangle here. We have a triangle here. And right here is 2. This is 6. This is negative 1. We can find the area of a triangle is equal to 1/2 base times height. So we're going to find the area of both of these. So the area of T1, let's call this T1, I guess, is equal to 1/2 base is 3, height goes down 6, 3 times negative 6, it's equal to 1/2 of negative 18, that is negative 9. And now, we are going to find the area of triangle 2. Area of T2 is equal to 1/2 base of 4 times height of 8, which is 1/2 of 32, which is 16. Now we add these areas together. It is negative 9 plus 16. equal to 7 squares. 7 squares is the total area. Now let's look at B. Let's look at 3B. What are we going to do for this one? So on 3B, let me find my question. Just finding my question. Find the area under f of x equals 2x minus 4 on negative 1 to 6 using integration. Integration, otherwise known as power rule. We're going to use power rule for this one. And this is personally my favorite. I just find it really fun and satisfying. Actually, I don't have a favorite. It's all equally fun. I'll just keep it at that. So in this case, we're going to find the integral of f of x dx. Otherwise, the integral of 2x minus 4 dx. Keep in mind, we have a lower and upper bound that is negative 1 to 6. So this is a definite integral. We're finding the definite area, exact number, if you will. So let's use integration. Integration, power rule. We're following the parent generic function that tells us the integral of x to the n is equal to x to the n plus 1 over n plus 1 plus c. That's what we're going to do. We don't have to add the c. It will be irrelevant in the end, as you'll see in a bit. We don't need to find the c. So we're going to take the integral now. 2x to the 1 plus 1 over 1 plus 1 minus 4 to the x of 0 plus 1, 0 plus 1 plus c, of course, is our antiderivative. Is our antiderivative of the function. And we're finding this from, keep in mind, negative 1 to 6. So we're going to plug in our upper and lower bound, use the fundamental theorem of calculus, which tells us the antiderivative of from a to b of f of x dx is equal to antiderivative of b minus antiderivative of a. Remember, we're finding the area from the upper bound minus lower bound to just find our targeted interval. So we're going to plug in our 6. This is our upper bound. I guess I'll show you guys. Just rewrite this. That is 2x squared over 2 minus 4x plus c. Let's plug it in. X, this 2 will cancel out. Divide to 1. Not x. 6 squared minus 4 times 6 plus c minus, there's our FB, capital FB, minus negative 1 squared minus 4 times negative 1 plus c. And let's just solve these parentheses real quick. 36 minus 24 plus c minus 1 plus 4 plus c. That is 12 plus c minus 5 plus c. And just distribute this negative sign to get rid of these parentheses. That is 12 plus c minus 5 minus c. And the c's don't matter, they'll cancel out. And you get 12 minus 5 equal to 7. Pretty cool, you get the same answer as you would using geometry. And we're gonna keep it going. We have one more method that we're gonna go over, and that is definition of the integral. So, 3c, whoops. 3c, find the exact area under f of x equals 2x minus 4 on -1 to 6 using definition of the integral. New method. And the definition of the integral kind of tells us that we will need to use the limit of Riemann's sums method to solve this problem. We'll need to use sigma notation. So the area is equal to the limit as n approaches infinity of sigma f of xi times change in x. And we're going to start out by finding our change in x. You go to b minus a over n, you know that, which is equal to 6 minus -1 over n. We don't have an n value particularly because we're saying that n is approaching infinity. That means we have basically an infinite number of rectangles, which is allowing us to fill in the tiniest of points to find the exact area. Pretty cool, pretty interesting. So 6 minus -1, that is the same as 6 plus 1. We have 7 over n as our change in x. And once we define our change in x, we can find our xi. Xi is equal to a plus change in x times I, which is equal to our lower bound, -1 plus 7i over n. There we go. We can plug that in now. Our area is equal to the limit as n approaches infinity of sigma for f of xi times change in x, otherwise known as the limit of n as n approaches infinity. And we're going to sub in our x for xi. Yep. 2xi minus 4 times our change in x. That is 7i over n. And I'm going to go ahead and rewrite this one more time because we know what our xi is, just showing you guys steps in full detail. The area is equal to, let's just put this change in x in the front, save it for later. That is sigma of f of x, which is equal to 2 times -1 plus 7i over n minus 4, which is equal to, whoa, maybe you guys caught me. Area is equal to the limit, obviously, 7 over n. So we're finding the limit approaches infinity of, that would be -2 minus 4. That is -6 plus 7i over n. And I did say I was going to move it to the front. Doesn't mean we can't just move it to the back whenever we want. This is the same thing, don't worry. Don't worry, okay. And now we are going to go keep sort of chopping away at this, simplifying it. And this is not an I, it's just 7 over n. And we're going to split this up because it's going to help us sort of figure out how we do this a little bit better. So the limit as n approaches infinity of sigma -6 plus, get these brackets in there, plus sigma I equals 1 of 7i over n. Of course, times are changing changing x. Let's keep simplifying this, when you don't have any sort of I variable attached, you can kind of just multiply it by the n. This is an infinite number of rectangles that we're multiplying by, -6n, plus we can take this 7 over n as a coefficient and keep it outside to the I times our change in x. And what do we do with this I when we have in a sigma? This I will turn into, or when we have a just I to the 1, this is the same as n times n to the 1 over 2. That is what we do. So let's try to further simplify this. That is the limit of the function as n approaches infinity, -6n plus 7 over n. And when we rewrite the I, we're going to be able to get rid of this because we can just sort of apply the n to the I now, such as we did to the -6. So I'm just going to go ahead and condense this a little bit and then split it up. N squared plus n, and this is all over 2. I just distribute the n. N squared plus n over 2. And I'm going to distribute this. I'm going to distribute the n to both of these terms. Let's see what we get. That is -6n plus 7n squared over 2n plus 7n over 2n. Which is equal to okay. Now I know what I did wrong. My mistake. My mistake. I totally forgot to multiply this by 2. It's supposed to be a 14, guys. Come on. 14 that we distributed. No need to worry. We're still doing the right process. And as you can see, this 2 will divide the 14 into 7. This n will divide out an n. This n will divide out an n. So, rewriting, -6n plus 7n plus 7. And now we're going to bring in our change in x to multiply. Our limit as n approaches infinity of -42, 6 times 7, -42n over n plus 7 times 7, 49n over n plus 49 over n. N's will cancel out. And let's plug in our infinity now. So we're just left with -42 plus 49 since we canceled out the n's on these terms. And we're left with 49 over infinity. And this is an infinitely big number on the denominator. So we know that when we have an infinity in the denominator dividing really any regular number, it's going to come down to 0 because we keep dividing. It gets super, super, super small. So we can just call this 0, and we get negative 42 plus 49 equal to 7 for our area under the curve. And we have achieved the same answer for all forms of finding the area under the curve. And super cool, right?